Welcome back. In this tutorial, we will continue talking about data analysis. Specifically, we will be looking at a new package called Pandas. And in Pandas, we will be looking at series. It is one of the two important data structures in this package. The other basic data structure is data frame. We will look at that in the next module or the next video. Okay. Today we'll be working on series, and we will talk all about how to create a series, how to work with the series. Okay, that's on tap for today. So now to start, we will do the usual. First, we will import NumPy as NP. Okay, and remember we talked about NumPy in the last video. It's one of the basic data analysis packages that's quite handy. So we'll be using that quite a lot. So import NumPy as NP. And we would now be importing this new package called Pandas. Okay, and I'm going to be using the pseudonym called PD, right? Import Pandas as PD. Like we discussed in the last class, I can choose not to have this if I decide that, right? Then I would be referring to any Pandas related library function as pandas dot. Okay, so I don't want to type in pandas dot, so I want to use PD shorthand for pandas. Okay, and I also do one additional thing. I basically say from pandas import series comma data frame. So what I'm saying with this third statement here is that I know that I'm using pandas as a general purpose package, but I also will be working a lot with these two specific libraries called series and data frame. So I don't want to be typing many times PD dot. If I don't do this, then I may have to do PD dot series and then use a function. So I don't want to do that. Since I will be working with series and data frame a lot, I choose to import this directly so I can work on it, more easily without really typing in a lot of prefix. Okay, so from pandas import these two functions, series and data frame. Okay, and of course this module we will be looking only at series, not data frame. All right, so let's get started. First things first, we need to create a series. Special data structure, right? Looks or might look like a list, or might look like some of the data structures in Python, but really they are created specifically for data analysis. Again, very similar to ND arrays in NumPy. Special purpose data structures created for efficiently processing data. Okay, so now let's start by creating two lists. One is a numerical list here, 25, 35, and 50. I just arbitrarily created these numbers. Okay, and I assign this to this variable lis. It's a list structure in Python. I also created this second list called ind, right? And the elements of this list are January, shorthand for JAN, January, FEB, MAR, and so on. Okay, so I have two lists here, and I'm now going to try to create a series by using these two lists. So I basically type in series, that's a function, right? And within parentheses, so what's the data values I'm interested in? LIS, that's right here. And this is literally my index. So I'm going to be using these months, right, as index values in some ways. So one way for us to think about this is that this data structure, this series represents, let's say, average temperatures in New York in a specific month. Okay, so then January would be on average 25, February would be on average 35, March would be on average 50. Again, remember that the context that I added, average temperature for the month of January, or for the month of January, February, and March in New York, is the context that I add, right? For all we care, this could be completely something different. Could be in Boston, could be last year, right? It does not matter. I'm just giving you a context so we can think about this data, in a more concrete manner. Okay, so I create this series using these two lists. Okay, LIS, comma, and then I assign the second list as the index. So I have to type in, this is the syntax, index equal to, this is the variable list, right? So it could be X, Y, then you would have X here and Y here, but otherwise you would follow the same format. Okay, and I assign this to this new variable called temp. Okay, is the series. It will be a special Pandas structure. So we'll continue, let's run this code, see what it throws up, and then we will be continuing to talk about this structure, examine the structure, just as we did for NumPy. Okay, NumPy is ND arrays. So let's start. Let me run this code. Okay, I made a mistake. It says name series is not defined. If you can take a moment to think about why this might be the problem, maybe because I did not run this first cell before. Again, remember, we're using Jupyter notebooks. Oftentimes, we have multiple cells, very, very, very good, very useful for pedagogical purposes. But sometimes you have to be careful. Have you run this previous cell? So let's try running this. It's not recognizing series. It doesn't know what it is. So maybe I need to run this first. So I ran this. Now let me try to run the second cell. So it worked. So now we've created this structure. Let's call it variable name is temp, T-E-M-P. I assign this as a way of thinking about temperatures, right, in New York. Let's say average temperatures in New York, according to these for these months. Okay, so let's see what data is actually now in temp. So I'm going to run the cell. So you see that you have two columns here, Jan, Feb, March, right, in the first column, and here's your temperature, average temperatures, again specified by me here, right, as a part of this list. And then I use this list to create the series. Okay, you also see this fourth line here that basically says that the series is integer type. These are the critical numbers here. These, by the way, are the indices or indexes, index numbers, right, or index values rather. So we've created a special structure, data structure, with this kind of appearance. Okay, so now let's confirm, just to make sure that this is actually a special structure. What type of data, data type is this? Does this variable temp belong to? So let me run this next line. So you do see that it tells you here it belongs to this special data type called pandas.core.series. Series data type is series. Okay. Now, one of the ways for me to think about this, right? Think about the series is, if you go back to Python, again, I'm going to go back up here. If you see, I basically say here, it's almost like an ordered dictionary. If you remember, Python has this really nice data structure called dictionary, but it's an unordered. I mean, it's not ordered by key values. If you remember, when you put something in the dictionary, when you try to print it, you cannot predict the order in which the different elements or items of the dictionary are going to be printed, because the keys are not ordered. Unlike an index, where you have 0, 1, 2, 3, 4, 5, and so on, right? And you can actually expect 0 to be before 1, 1 to be before 2 as an index. So this is you can think of this as a dictionary, but only it's not unordered. It's like an ordered dictionary, because we do have indices that we can refer to, and they are ordered. First in, it's always going to be printing in this order. Okay. So now let's see if there are ways that we can access the values in this series. Of course, I can type in temp. I can also do print temp, right? Which is what we usually do before. I'm just using temp because it's much easier for me to use the interactive feature of Python. I might as well have done this, and I would see somewhat similar output, right? Now, is there a way I can just access the values of the series, right? These numerical values. So the syntax for that is the variable name, that's temp, right? Dot values. Again, I can do print. I'm choosing not to do that because it's simpler. You can clearly see what I'm trying to do, right? So let's try to run this, temp values. And interestingly, you'll see that it looks like somewhat like an array, maybe an ND array from NumPy, right? So 25, 35, 50. So here's what you have. Here's what you have, an array of values, right? That are now specifically assigned to indices or index values, okay? So what if I wanted to retrieve the index? So again, simple. I have another syntax here, variable name dot index. So let me run this. So you would now get the index as an output, okay? And it belongs to a data type object. This is what Python is telling us, okay? But it's an index, all right? Now, if you want to access elements in a series, right? So again, we would go back to that square bracket. Again, similar to the way we accessed data structures in Python. So variable name, square brackets, and put in the index here, right? For dictionary, this would be a key. So we have something called Jan. So we say temp Jan in quotes, right? And let's try running this. We should get the corresponding value. Okay. So what happens if I type in something that's not present? Let's say I do May. right? So you should get expectedly, right, something called an index error. Because it doesn't exist, you're not going to get the value. So we change it back to Jan and run the code again. So you see 25. Okay. And again, similar to before, we can also check whether the particular key index value is present. So I can say Jan in temp. Right. If it's present, then it's going to say true. If not, it's going to say false. So I can check whether the key exists, or in this case index. I'm using the word index and key kind of loosely here. I can see whether the index exists in this particular data variable in the series, in this series. Okay, so it does. So I'm going to get true. If you try May in temp, you'll get an error message. You would not get an error message, rather you would get a false as a response. Okay, and I can also do some of these other neat things where I can say, think about this. I have this variable called temp, and in square brackets, I'm basically saying, give me values, that are greater than 30 in some ways within temp. Okay. Again, this is the syntax. Of course, this can change, right? So I'm going to run this, and now you would see that out of the original values, I'm going to go back up here. There were 3 items here, right? One was 25 less than 30, but the other 2 values are more than 30. So you see that those 2 values are printed here. Okay, so I can access elements, in many different ways. Directly access it using the index, or I can even run some logical operation to see I want to select specific values that satisfy a particular criteria. Okay, I can also assign name to this series, right? Temperature, but sorry, for Python, this is the name of the variable, no question. Temp is the name of the variable that refers to the series, this series. Okay, but I can formally assign a label in some ways to the series. So all I need to do is temp.name equal to average temperatures in New York. Okay, so what I'm going to do is, to make things clear, I'm going to insert a cell above. Okay, print temp first so I can see what the output is. So here's your output. Now what I've done is I've assigned a label, or assigned a name to this series, and I call this average temperatures in New York. Okay, now I want to print name again, sorry, temp again. Now you see at the very end that in addition to the data type, which is an integer, it's added another descriptor, the label. Name of the series is average temperatures in New York. Okay, otherwise you have this still here, nothing has changed. Now let's say that I also want to give this a name, these index values here. Okay, so I could perhaps say temp.index.name. Again, this is a syntax, equal to give it a label that you think is appropriate. Okay, so once I do this, if I try running this code, so you can see that the only change now is on the top left hand corner here, you have this caption or label that describes what this column is supposed to be all about. Okay, so hopefully this is clear. And this is the basic data structure series. Here are some of the ways you can create it, some of the ways you can access the data inside and work with series. Okay, now I want to show you a few other things. Again, you may have noticed that I referred to this early on as kind of like an ordered dictionary, right? So I can actually, because it kind of looks like a dictionary, only it's ordered. So what I can actually do is, I'm going to go down here. I can convert a series to a dictionary using this method. So here's a variable name, temp dot to underscore dict, open parenthesis, close parenthesis. Assign that to a variable. I'm going to call this temp underscore dt. Bingo, I've got a new variable now, temp underscore dt. That is a Python dictionary. Okay, so now it pretty much looks like a Python dictionary that you're used to. And just as you can convert a series to a dictionary, right, you can also convert a dictionary to series. So let's try to convert this temp dt, right, which now we know is a dictionary. Let's try to convert this to a series. So what I might do now is use this syntax, series, open bracket, close bracket, temp underscore dt. That's it. Series is, if you notice, I'm going to go back up here, right? This is what we use. right? And this is how we created the series. We had two lists, right? One for values, one for the index. And we used this function to create the series. Now here's a second way of creating series. Let me navigate my way down here, right? All I need to do now is much simpler. Instead of using those two lists and specifying which one, right, is the index, now I just simply say, here is a dictionary, temp_dt. And that should create a new series. Here we are assigning this to a new variable called temp2, right? Let's run the code and see what temp2 is. As you can see, it should be pretty similar to what temp1 was, okay? And finally, I want to do one other thing, okay? I want to show you another way of creating very slight modification, a slight refinement of the way of creating the series, right? So now let's actually create another list called months. Jan, Feb, March, and April has 4 values in here, right? And now let's create a series. So use the same function, use the dictionary, right? The dictionary that we had before, which is if I navigate my way back up here, here you have Feb 35, Jan 25, March 50. And again, I forgot to mention this. Note that when I printed it, it printed Feb first, right? Unordered. So when you lose the order, sometimes when you create it back, when you move it back, that can change here, okay? But here you have your dictionary, but still the values themselves won't change, obviously, okay? Now here you have your temp_dt. So what I do now is now explicitly write index, again very similar to what we had before. Here the first time we created this, right, we actually had two lists. Here's a list and here's a list, right? But we use the syntax called index equal to. So we're doing something similar, but only here I'm using a dictionary, right, that has currently these 3 keys and these 3 values corresponding, right, corresponding to them. And I'm basically now specifically saying use this as the index, right? And if you notice, January, February, and March already exist, but there is no April, okay? So let's see what happens to temp3. Is it going to be successful? Are you going to see an error message? Let's see. Let's run this code. So something interesting has happened. Now we can see that you have January, February, March, and you have values, right? But you also see that you have a 4th value added on to the index, April. And here you have something called NaN, like a null category. This is basically means there's no value present, right, or assigned to this particular month. Okay, so you get something that's a combination of the two. April is missing in the previous dictionary here, so you simply add April as an index, but say null, there's no value present. Okay, now what I could try to do is introduce another simple function called isNull. So if again, this is from the Pandas library, so I cannot just say isNull, I need to specify pd.isNull. Okay, so here's your Pandas. I said import Pandas as pd, right? And before, I don't need to, for series and all that, I don't need to specify pd because I used a variation of this to import it. So I'm using a shorthand. But for anything else that's not series and data frame, I need to go back and make sure that I refer to pd. So I'm going to come down here, okay? So pd isNull, this new object, this new series, temp3. All we are asking is, right, is there a null value present in this series? Okay, so let's see what the result is. So basically what you get back is another object, right, where the value is Boolean type. If there's a value present, you're going to see false. So false, false, false for the first 3 items, right? And the 4th one is a null value, so it's going to say true. So you get back a different object that looks just like this. And of course, I can do the reverse of it simply by changing this to not null. Okay, I'm running this again. You're going to see the inverse of what was there before. Okay, so again, what we did today for this particular module is to introduce you to a new fundamental important data type called series in Pandas. Okay, and again, we are not getting into the details of series. I just wanted to get you, up and running very fast. So we only need to know the absolute basics. Okay, so I don't want us to get lost in the details, gory details of all these objects. Okay, at a later time, I'm going to link you to Pandas documentation so you can take a look at all the different ways of creating series and data frames. You can also look at all the small details in terms of how to specify what data type a particular value should be, and so on and so forth. And finally, before I finish, I wanted to show you some very basic things. Even though it's optional, I specifically mention it's optional because I don't want you to worry about this for the exam, but I would encourage you to stay and have a look. Okay. So note that, so here's the optional content, some more additional things that I want to tell you. We now have two values, temp and temp3, that are kind of similar. Okay. So if you remember, we created temp, this is temp, right? And we also created temp3 at the very end, that looks like this, right? What happens if I have the command called temp plus temp3? I'm adding the values. So do you think they're going to add values? Let's run this and see. And yes, they did. So you have April as NAN, okay? February is 70, Jan is 50, March is 100. Okay, it simply added the values. Okay. So again, obviously in this context, it does not make sense for us to add, right? These are average values of temperatures, but in the future, maybe in a different situation, maybe you have the grades of students and you want to add the grades to compute something. Perhaps then you can simply perform this operation. Okay. So this kind of operations are possible with series, obviously. Okay. And finally, what I wanted to do was, here are a couple of ways, quick ways of creating, like other ways of creating series. Okay, so we are going to be using very similar syntax as before, right? Here's a variable that I'm assigning this serial to, right? Series1, SR1, right? Equal to, here's the key syntax, series, open bracket, close bracket, okay? So, and you also notice that instead of lists or dictionary, I have something here to create a NumPy array, right? And if you remember from NumPy, I can use the arange function. It's going to create a list with 0, 1, 2. Up to but not including 3, right? So quick way for me to generate an array, NumPy array, okay? And the rest of the stuff should be very similar. I'm basically saying here's a new list, R1, R2, R3, each of them in quotes, assign that to the index. And again, if you notice, there are going to be 3 elements here, 0, 1, 2, and correspondingly 3 index values here. And now I'm basically saying assign this to SR1. Now, what is SR1? Let me run this. Unsurprisingly, R1 is 0, R2 is 1, R3 is 2. So quick and dirty way of creating index. Okay. So here's another way. It's another variation rather, not another way. Similarly, I can say arange 4, index numeric values 1, 2, 3, 4, assign that to SR2 and try running this. So instead of R1, R2, R3, which were string type here, right? I have numeric type as index, and here are the actual values that are integers. Okay, and it's a third type. It's even more simple, even more basic. I do not even need to specify the index by default. Okay, so I can simply say SR3, another series variable that I'm going to assign to SR3 series, open bracket, close bracket here, NP arange 10 to 100 in increments of 20, but don't include 100. Right? So let's see what happens. So what happens to the index? By default, what is going to be the value? Think about it. It should be able to guess. By default, it's going to start numbering at 0. If you do not assign index, Python or Pandas library in this case will automatically start at 0 and assign it to the first value, and so on. Okay? So this should be fairly clear now. There are multiple ways of creating series objects. Some of them pretty fast, quick and dirty, very easy, okay? And they're very, very useful for us going forward in working with data and analyzing data, okay? So now, I just want to add one other thing I couldn't resist, very last thing I promise. So you have SR1 here, up here, with three items. So let's print this, okay? So here's your SR1. What happens if I wanted to drop the first row? Let's say I don't want it. Again, simple. All I need to do is dot drop SR1 series, right? Dot drop, this is the variable. In parenthesis, the key, R1. And now let's try to print it, run the code and print SR3. You will notice that R1 is gone. Okay. So again, there is so much more to series and pandas and data frame. Here we have the very rough basics that you need to get you started. Okay, at least for our class and for the project. So this brings to a conclusion our lecture on series. What we are going to do in the next lecture and in the next video would be to introduce, or rather to start talking about this very fundamental and very important, the most important data structure for this class, which would be data frame. Okay, so I look forward to seeing you in the other lecture. Thank you.